Hi folks, this is Sarbjeet Johal coming to you from IBM TechXchange in Las Vegas. As you all know, that GenAI has taken the computing world by storm, and the narrative has shifted from the chatbots to co-pilots to now agents within these 24 months or so. Agents are talk of the town. In that context, we have a great guest with us, Mr. Ruchir Puri. He's chief scientist at IBM Research, and he is an IBM fellow. Ruchir, thanks for joining me today and finding some time to talk to me about Agentic frameworks for enterprise application development. I saw your keynote yesterday, and that was great. So with that, give us a sort of small introduction of your role, and then we'll get started.
So first of all, thank you for having me, Sarbjeet. It's a pleasure to be here. My role at IBM Research and IBM broadly has spanned 29 years across business units and research. I led Watson as its CTO from 2016 to 2019, and then came back to research as its chief scientist. And my role is really to watch out for sort of disruptions in technologies that are upon us, but if I may say, predict them much ahead of time.
Yeah.
That's really our role, and obviously those predictions seems to be getting faster and faster and faster as we go on this journey of AI technology. So it's a really exciting time to be around technology landscape these days.
Yeah, there's no denial in that. With the GenAI, causing many companies' market caps like ballooning to 3 trillion from $500 billion to 3 trillion within like 2.5 or 3 years, and we know which company that is. And IBM is also doing great these days. And you guys have
we're delighted.
You guys are delighted.
And a lot more to come.
And a lot more to come. And employee morale is high. I know. Actually, it helps when the market rewards the efforts. So with that said, let's get started with talking about how agents will change, according to you, how we develop software, and then after that we'll get into like pros and cons and how we will make it work. We'll go a little more technical.
Definitely. So I think before we really get into just the agents and the software development itself, I always like to settle on why is this shift taking place? Like, why are we so excited about agents? And I sort of put this in a very simple terms. We are moving from a world where intelligence was baked into the model at pre-training time.
Yeah.
Like you train the model and say, all this intelligence is baked in, and you can fine-tune. Obviously, we have wonderful technology that you will discuss a little bit later with Instruct Lab and so on. But all of that is done at the training time.
Yeah.
We are moving into the era where you can start delivering intelligence at runtime.
Yeah.
Which is just like awe-inspiring, because you can do things that were never possible before. You can correct things. So not only can you predict, and not only can you take actions in the real world, but you can look at the results of those actions, and if you sort of decide this is not going the right way, you can correct it at runtime, which you can do at the training time. So that's why when you combine all of this technology together, it delivers value and speed to the market that is unprecedented. Now, on to the main question that you asked regarding enterprise software application development. I think it's fair to say that one of the best applications of generative AI technology so far has been in software development. Yeah, coding assistants are plenty. We have our enterprise Watson X Code Assistant announcement here as well, the launch of it for general purpose programming. Obviously, we have had it available for mainframe COBOL applications and IT automation like Ansible and others before. But where we are going is really through the entire software development life cycle. As a software developer, rarely is my job only about code completion, if I may say, or help me write these 3 lines of code. It's my day-to-day as a developer is involved with, you come in the morning, you have a backlog of technical debt. Typically that technical debt is comprised of many GitHub issues.
Yeah.
Could be as many as 30 in a day. And you are looking at this and saying, okay, like, the way at least I talked about it yesterday is, and this is a typical day in the life of a developer.
I have done the development work, so I totally understand that.
So like you are at 7 p.m., you are about to close your Mac, and your technical lead said, Ruchir, that issue needs to be addressed right now.
That's severity 1.
Yeah, this is severity 1, doesn't matter what you are doing, and you wish there is somebody to help you resolve that issue.
Yeah.
So you are moving from the world of doing piece pods to the world of handling complete tasks autonomously, which is the task of, for example, and there is a lot more to it, generating a pull request and a patch for the entire GitHub issue. And that to me is incredible technology, which is going to percolate through how enterprise software is developed, how enterprise software is tested, how enterprise software is deployed, and how enterprise software is operated.
As you were talking, there were quite a few keywords you said there. So one is a data infusion at runtime, right? So runtime can be relative term. Runtime for a developer is like while I'm fixing the errors, I'm doing like development, and then the repos are getting pulled out of GitHub, and that can be kind of semi-runtime, I'll say that. Like I have talked about the use of GenAI at design time versus runtime. At design time is a perfect fit. It's a great companion to human sort of know-how or our knowledge. But at runtime, it's a little more challenging. That's what I actually thought, like 24 months back, and still think in many sort of facets. So I think the key is that how do we infuse the data, actual data? I usually say that applications, enterprise applications, are codification of laws of the land. It can be law of the company or state or country and all that stuff. What is the interest rate for a bank, for a particular bank? What is the tax rate for a city? Stuff like that. So we can't let an AI model hallucinate, or just guess, right? So we need actual data coming from actual databases. So in that context, please shed some light on Instruct Lab and the art of data infusion into the models, which are very generic. You guys have a Granite model, and there are so many other models from other companies. If we start naming it, it will take like 10 minutes, I think. OpenAI has it, Google has it, and Microsoft is cooking some more. I mean, everywhere, right?
Yeah,
everybody has it.
Everybody has decent models.
So how will the private data be infused into these applications? Is it RAG? Is it some clever approaches like you guys are doing with Instruct Lab?
So I would say there is no one size fits all, and I'll describe it in following way. It is clear, I call these frontier models as jack of all trades and master of none. They're awesome. They're just awesome. But if I want to use them in an enterprise context, in a very narrow enterprise context, then I need to have them not hallucinate. I need to have them not veer off the guardrails that I'm setting up. And to do that, you need to ground them and you need to align them. If you're going to ground them and align them, there are multiple technologies available for you. One way of grounding it is obviously through retrieval augmented generation, also known as RAG. The advantage of RAG is that if you had data which cannot be sort of shared or not permissible for every user, you may decide you're not going to retrieve that data. So it allows for certain privacy aspects, if I may say. If you bake the data into the model, then you are going to benefit a whole lot more because your quality is going to be higher. Your inference cost is going to be lower because by baking the data into the model, you can actually get similar or better quality than a much larger model in a smaller model. So baking the data into the model enables you to have lower size models for the same task. So for example, I'll give you an example. We've been working with many clients from finance industry to insurance to obviously telecom and others. And what we are seeing is that almost everybody is to a reasonable extent working with some kind of frontier models. GPT-4 plus RAG seems to be a common scenario actually that a lot of people are playing with. And once they start getting to the point where they are starting to deploy these things, like they look at the cost and say, oh crap, this cost is like really bad. And that leads them to, could somebody help me reduce this cost for deploying AI at scale? Now, interestingly, what the POCs we have been running with them and very successful ones are about, you can take your knowledge and skills and your data, do instruct lab on that particular data, bake it into the model, into a 7 or a 8 billion parameter granite model in our case, which happens to be almost 2 orders of magnitude smaller than the GPT-4 size model, and deliver equal or better quality than GPT-4 plus RAG at 1/50th the cost.
That's amazing. I did play with the Instruct lab here. It's, I think, brilliantly done because it has an example of what is Instruct Lab, right? And then before the infusion of external data, it just pulls up some very old definition, which can be 20 years old or something, from Wikipedia or something. There's another term, Instruct Lab somewhere, right? But after infusing the YAML file and questions and answers and then creating synthetic data, after that it becomes like much smarter using NLP
and very fast actually. I think this happens at a very fast pace actually.
And I was told that on an M3 MacBook you can do all that work locally as well, but there are cloud
the back end to it as well. Like if you really want to build an enterprise ready model, it's going to take you a node or so to really get that model right. And that's the one, like the compute requirements for these are fairly reasonable and relatively very small compared to thousands of nodes needed for training a larger model, for example.
Makes sense. So coming to more so developer side, typically we use libs from the language itself. Python has rich set of libraries, and R for data science, and so many other languages, Java, right? And prior to that, we used to have DLLs in the Microsoft world, right?
I remember it very well, actually.
DCOM, DLLs. So infusion of like more functionality, if you will. And then API libraries, which are external from third parties and or open source. So we call an API and get something, and then we have logic, which we control, application developer controls. How do you see that getting worked out in this multi-agent sort of world, where you may need to, most probably you will need multiple agents within the same application? And when we talk about application in enterprise context, it is not just like simple, do this one task. It's complex in a way that it touches so many other systems, gets data from this system and massages it and passes it on to the other one. And there's a lot more touch points, like tens of or hundreds of servers are involved in and so forth, services are involved, if you will. So going from microservices to these agents, how they will interact with each other? Do we need an agent bus? Or like we used to have enterprise services bus to communicate between objects and all that? How do you see this working?
So I would really say this is the advantage of, so you got sort of individual agents. They can do multiple narrow tasks, if I may. A good example is the way we built our SWE agent. It's comprised of kind of 3 agents. One is a localization agent, which localizes your issue. Other one is an editing agent. The third one is a kind of a testing/judging agent. Now this is an agent that can fix your GitHub issues. There's an agent that does your unit tests for you, actually. There is an agent that goes and deploys things for you in a CI/CD pipeline. There is an agent that does, for example, SRE tasks for you, which is now at operation, sort of really when you are in day 2 operations,
ops
at the ops side. And you're going to have soon, because these agents are going to become relatively easier to produce, if I may say, you're going to soon have a proliferation of these agents. And your question really is very appropriate, that how I'm going to sort of coordinate among a lot of these agents. And these agents are built off sort of a fundamental construct, what we call TAO. Think, act, observe. Each agent is built with this construct. Think, act, observe. And how does it think? It actually uses an underlying large language model to be able to think. And of course, there's a critique model that can kind of check itself when it reflects and so on. And now, take that concept to the next level, which is I'm now given a much more complex task than individual agents, and I ask it to, here are the agents given to you, coordinate among these agents. What is the plan for coordinating among these agents? So think of it as almost like in an organization, there is a group that does something, one task. That group's task is to localize the errors, as an example. Now look at the technical lead, which sits above them and manages multiple of these groups.
So like a meta agent?
It's like a meta agent, actually. And the meta agent itself has this sort of a higher level loop of think, act, observe. So when it thinks, it says, I'm given this task, I'm going to map this task into multiple agents. What is the best way of coordinating the resources across multiple of these agents together? And that's the technology we demoed yesterday with this technology called Mark, actually, where you take a broader, higher level task, you're given many, many agents at your disposal. How do you map that over into a sort of multi-agent coordination and behavior is what becomes critical.
So MARC, M-A-R-C, right?
That's right.
Okay. Multi-agent resource coordination, is that what it stands for? Okay, cool. As a developer, there are a lot of connotations go in our minds. Okay, now, yes, it sounds pretty good in theory, but in practice, how will I trust an agent to do the master plan, the meta agent, and then also the sub-agents, like, hey, it will pull the right repo and it will help me fix the bug by making the right change. We still need humans in the loop. Is that how you see it?
So I would definitely say, for until you get to trust the agent, you want human in the loop. You do not want an automated agent to go ahead and make the pull request for you and deploy things on your behalf until you get to blindly trust that agent. And that's precisely why when I demoed this yesterday, I said, here is where I found the error. Here is where the edit is. Here is my proposed edit. Here is reasoning for my edit. Can you sign off on this?
Somebody has to still sign off.
Somebody still has to sign off and review it and say, yes, that makes sense, actually. So you need a human in the loop for making sure in a mission-critical enterprise application, things are done the right way. But, and I'll put a but there might be other things which are innocuous. Like, it's okay.
True.
I kind of trust you. These are kind of, if I may say,
logging and stuff like that.
Logging. There are many tasks I can think about on a day-to-day basis that we do. We'll say, even if there was like something wrong, like the world wouldn't fall apart. So
Ignorable exceptions.
Yeah, exactly. So I think what we are looking at is, yes, you need a developer in the loop, absolutely yes. But it depends on the criticality of the task, and I say this in all honesty, automation is all about trust.
Yes, true.
Sort of the simplest example I give is, everybody drives their car in the morning every day, almost every day. You get in the car, you start the engine. How many people in the world understand how does the internal combustion engine work? Very few.
99.99%.
Even mechanical engineers would have forgotten the thermodynamic cycle, actually.
True.
So you trust the technology to take you from point A to point B, and if there is something wrong, you know where to take that car to. So I think to me, what is most important is for us to be able to have this agentic technology to be able to help solve our tasks, but keep us in the loop until we get to trust the technology. And at that point, you can get, sort of let your hands go a little bit.
Awesome. One last thing. Help us calm our nerves, I call it. There's a lot of anxiety in developers, architects, and practitioners of the technology, and even the decision makers, the CXOs, CIOs, CTOs, about like how the practitioners should take this technology and how like they should get their feet wet gradually and then get into this.
So I think our perspective is, and mine in particular, I would say, is that enterprises have large investments in digital technologies, very large investments.
Yeah. Trillions of dollars.
Trillions of dollars. And even more than the investment itself, their investment in skills, their investment in processes, their investment in sort of compliance processes.
Yeah.
Even if you wanted to change it today,
You could.
it's not possible.
You couldn't, yes.
Because there are regulatory bodies that actually are looking for, depending on what area you are in. And for rolling out these very powerful technologies, you need to leverage your existing investment.
Yeah.
Which actually is what is also wonderful about agents. Because one thing I would say is that agents are not just about solving complex tasks. The agents are about solving complex tasks, leveraging the current tools and processes that the enterprises have. Simplest example of this is, try to give GPT-4 or ChatGPT a question on adding two numbers. Likely it may get it wrong, because it's not a next token prediction problem. Can somebody tell ChatGPT to use a calculator? We have used it for 1,000 years.
Yes.
So to me, it is really about leveraging existing investments that gives rise to this natural progression of, really starting from where you are, growing it incrementally over time, not just in terms of enterprise progression, but your skills progression as well. So every enterprise must have a AI roadmap, but they also must have a skills roadmap as well. Because you're going to take the people that you have, they understand your existing estate, your existing processes amazingly well. You're going to take that and infuse AI into this. For that, you're going to need, obviously, the growth or a journey of the enterprise itself, but also the journey of people who are building those processes and those capabilities as well.
Awesome. With that, actually, we have very limited time. I'm being told that you cut it off right now. So thank you very much, Ruchir. Appreciate your time. I look forward to having another discussion with you sometime soon about the runtime and then not focusing on the developer side only or SDLC, but past SDLC and how we will build the complex systems. So thank you very much. To the viewers, thanks for watching, and stay tuned for more content.
Thank you, Sarbjeet, for having me.
Thank you. Okay, great. Thank you. That was good.
That's good, yes.